This is the third video for explanation our code. So PSO main loop is started with the iteration, as you see here, from 1 to maximum iteration that we defined before in our code. So, and after that also we started to update the velocity of each particles, how to the speed of particle to award the best position, and this is the function. Weight multiply the current velocity, so after that plus constant multiply random and particle best and current position, and also the global best minus the current position, and after that applied the velocity limits on the new velocity, and after applied the velocity limit we updated the position. As you see here, this is the position, the current position, the new position here equal the current position plus the velocity, and after that also we applied also the limited on the position, because the position we have also limited, so we applied, and the random the to 0. Why do you mean that? Because the particle position is the index, not the values. It's the index, the number of line line 20, number of line 11, number of line. This is why you random or round to the index or integer. So we optimize the index, not the values. So, and after that we also applied, as you see here, the line configuration constraint on the new particles, new particle position. And after that if the factor equals zeros, not change, so this is the configuration is applicable. You can make it the load flow, and if not, we will not we cannot the program make the load flow for this configuration. So we applied the 1000 10,000 as a cost, and after that we apply two things, as you see here. Updated the personal best. The personal best we for the old and the new. This is the new cost, and for the best cost, and compare between them. If the current cost is less than the best cost, so we updated the best particles for each position, and after that also we updated the global best, where we compared between the best cost or the current best cost with the global cost. If the current best cost is less than the global best cost, so we updated the global best particles and cost, and after that we repeated for all the number of population. And then after finished from the number of population, we printed this iteration the value of the best cost, as you see here. And then we repeated this process for the number of maximum iteration, and printed in each iteration the value of best cost. And after that also we stored the global best. After finished the iteration, we stored the variable global best in the best solution, and after that also we figure the best cost, how the best cost is behavior with iteration, and then after we apply plot the best cost. We applied the best position or the best configuration on the line configuration to calculate the line, and to define which line is open. So, and after that also applied the line of the best global best position on the load flow to make some get some result and plot some plots. And after that, maybe that to print the result, we will explain that also. So, and after that we get to the power loss, reactive power loss, and the V buses for the all passes, and after that also we printed the power loss before reconfiguration as a constant. You can get it that from the code that will send to you before. The name of the program is normal load flow, and after that we also printed the power loss after reconfiguration, so we can compare that, because after reconfiguration should be less than the power loss before reconfiguration. This is for to compare, and after that also to display the optimal open line as a line, the number of line. So we will explain also the result later. This is the PSO. In the next video, we will continue to explain the other code file. Thank you for your listening.